Either owner, whomever you are, and I'm sure we'll have some other people coming through, and hopefully I'm over at Canvas. And once we get started here at 6 o'clock, I'm going to let everybody know about what happened last night. There was a system failure, and it was not good. So was not exactly the kind of evening that we anticipated. So, and I've got some vocals, so you can hopefully you can hear me. I'm gonna find out. When I get this, I get the owner, and if you unmute for a moment, I'll unmute everybody. Who am I speaking with? Can you hear? Okay, can you hear me? Okay, hi Dylan. Glad to have you aboard. Dylan, how are you this evening? I'll unmute you there. Dylan, can you hear me?
Yeah, I can hear you.
Great. Okay. Yeah, I appreciate you showing up tonight. I know it's not what we scheduled, and glad I see you there.
Very cool.
Yep. And I'll diminish this down because the screen will get a little bit too crowded there, so I'll mute the video on us. Now I have somebody that keeps popping up as owner. I don't know who that is, but I'll mute us down here because it'll get too crowded for us to work. But I'm very sorry about last night. I'm going to apologize when we get started here with everybody. Yeah, I don't run the train, so if it goes over the cliff and I'm riding in the caboose, I don't know till we're over the cliff. And apparently they had some problems, and I'm going to have to try to figure out something. I'm going to have to try to figure out something to do about it. So hopefully we can get rolling. All right, but let's see. I've got this jewel. I'm recording it, so I'm going to go through what we would go. Well, I'll go through what we would have done last night. I'm sure there are other people. We may have a few more, but I'm not. I'll be surprised if we have a ton of people because people have lives and plan stuff, and it was pretty frustrating yesterday, to say the least. All right. And we'll get rolling here in a minute. That's not Santa Claus. That's my dog.
Mm-hmm.
Well, I'll go ahead and get it started. We may have a few more join us. I got quite a few emails yesterday, but and for those of you who aren't able to attend tonight, but had got tried to get in and couldn't, the system went down. Canvas was down, the email was down, and they didn't get everything back up till this morning. And I sent everybody a message through Jupiter grades, so I hope everybody got that. I'm very sorry. I do apologize, and if it creates any problems in terms of people getting their work in, I'm going to be pretty careful about that. And I've got to find an alternate. It was my fault for trusting the system over there to work, and I'm So there's a case study in IT failure. We're over here this week on the, we're work on the week of the 8/29, and which is the 5th of September. And I want to just go through some of the resources we got here before I start going and we do a little bit of work. And again, what we'll do an hour and a half, maybe 2 hours, the very most, and then I'll do some supplemental workshops. But I do have some resources here that I want everybody to take a look at. I'm not going to give them a test over, but these are charting and dashboard resources and resources for, they're really around infographics and the visual display of data. And I want to go over to, I think it's the New York Times, if I'm not mistaken. I want to let everybody see this because it was pretty awesome. They had a incredible map that that they were showing, and it was interactive. It was showing that as the storm was occurring, going across, and like a dummy, I should have kept the link, and I didn't. So that kind of blew that one. But they were showing a and maybe this link will take me here, unless they're going to give us these pictures and so forth of people. But one of the things that's interesting that happened is that here it is. Now I'm going to open this map up. This is a piece of it. Yeah. Now, as I mentioned before, we're moving into the database piece of the course, and really what you have here is a map with locations requests for assistance. Now, I hope nobody has anybody down there. If you do, we're all offering our prayers for them, and it's a terrible, terrible thing. And you can see the clusters where these rescue requests were going on. And as I understand, there's still thousands of people that they're still trying to get out. And then, of course, Louisiana's got its own barrel problem. But this is a way to show you, the level of flooding. And you can see over here very few requests, because primarily this is upper ground. This is a little bit higher ground. This is a little bit more depressed, or a lower relative to the ocean. And so you can see that. This was another map, okay, that I wanted to show everybody. And this is using some, not a thermal, but showing locations where they've got people being taken care of. And again, you can see these are the types of shelters being provided by these different locations. So again, another mapping thing to let people know what's going on. And this map here walks through the flooding that's going on, and if levees or water banks or rivers or anything have overflowed, nearly overflowed, or contained. And this is a fairly decent map, although this should be a different color than this, or these three should be a thermal. And I know we're talking about people's lives and so forth, and so it seems picayune, but this is kind of a hard map to interpret. But if you look at it, you'll see that some of the main thoroughfares in a lot of the central city, they've contained, and that really has been by design there. The rest out, these exterior kinds of areas in the city have overflowed, primarily because they just don't have the infrastructure that they do in the city. Now, this shows you the flooded high water incidents and around. one of the things I wanted to share with everybody is we move into the database portion of the course is something quite interesting. As I was listening to CNN, one of the things they were doing is CNN had reporters out, and they drive and they go by a house and they say, "What's your address?" And the people would give them an address. And I don't know if anybody, those of you who are here tonight or who will listen in, have ever been in a flood zone or worked a flood, but it's impossible to find anything if it's as high as that. It's bad enough when it's more of a typical flood, but literally the streets disappear, landmarks disappear, and what you really have is just housetops. And so the way they find those people, and this is again one of those remarkable things about databases, is when they get an address from people, okay, then they're able to go into the geographic information system and locate where they're at. And so as the rescue efforts have gone, they would and people would call in, and the emergency people there also were able to take phone numbers, and they were able to locate the phone using GPS. They can do that. So this is one of these things where a database doesn't seem that important, but yet it's a real lifesaver. And it reminded me a lot of the work I got involved in when we had the 2013 tornado here in Moore. We did part of the relief effort. I'm a member at First Church in Moore, and one of the things we did, I helped them we put together a database as people were calling in trying to find their relatives, and we'd have people who had lost the cell phone and were trying to, they'd come in and go, "I got to call my relative," and so we set that up. The other thing was we set up a database to make sure we knew where all the inventory was, and we created a map for everybody because the parking lots up there were completely full. So I know these are tremendous tools, and I know the way they only found many of those people was they used GPS to hunt the location, because there are no there are no landmarks. And I remember in the tornado that as you left and you went out west of town out towards I-44, Interstate 44, it was so flat. There were no street signs, and they use the same techniques to go try and look for people and find people. So this is sadly it's a horrible tragedy, but again, you can see how we can use maps to get information out about people. And this shows you some of the infrastructure that was shut down, major airports, and giving people again a sense. And this is a topographical map, and what we mean is and it has roads and streets and interposed over but this shows you it shows you relative elevation, and so you can see a lot of the city there. In a lot of the city, Houston is on a bay, and a lot of that city is in a lower elevation. So that's one. This one I thought was an interesting map, and this was looking at the median household income, which really has nothing to do with anything. But it would be interesting to go back and overlay that with where some of the infrastructure is. But as you can see, people with higher incomes are, obviously are in what one would now call the exurbs. So again, this is a database with a thermal superimposed using income. And so it was some really good stuff. One of the interesting things that happened, and this, I believe, I saw it on AOL, and someone else had mentioned, but they had such heavy rainfall totals that they had to invent a new color to put on their maps. This, I think it was the Weather Channel, and because of the amount of rainfall. So again, this is This is one of these good examples of stuff that goes on out in the real world, and I would encourage you to follow it as you go along. And I'm sure if we went over to the weather channel, you'd see some really incredible stuff over there as well. And I wish I could have found that 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 map. It was yesterday, and and what it really here's what it did. The map, it was a map of Houston, and it would show hour by hour. It would change. It was a thermal, and it would show hour by hour as the water built. It was incredible. And I should have saved it, and I didn't. And if I can find it, if I can find it at some point, I'll try to get it and maybe send an email out to everybody. So again, now this week I'm wanting to kind of talk about infographics, visual display of data, and that's one big piece of what I want to talk about last night. Now the second part of this is obviously, and here's another resource that covers this issue of graphic display of data. These three resources right here, binary and then the ASCII and the relational database, are important to have, and there's important sources to understand what modern databases are and what they do. And when I first started working on databases, okay, they utilized a process called a pointer. And if you had a database and you created a database, you literally took up space in the computer, okay, and you had pointers to a particular address in the computer. And that meant that people had to build bigger and bigger computers, and then came the integrated chip. But along with it came the idea, the notion of using taking ASCII, okay, and trying to expand on it, and the SQL structured query language was developed. So that here's what happens. When you run a database, you pull data from a table. Now, if you save a table or you create a table, the table is physically present. It has a physical address in an array in the computer. But when you you can't change that table unless you have that level of permission. But when you run a query, what's there, what gets saved is basically the underlying SQL and then the result set. So it's kind of like taking a picture. And when we made that transition, that took databases into a completely different level, and along with high-speed computing and all the things that we can do with them now, are primary that. So when you go and do a Google search, you go buy something at Amazon, you're running a query or you're entering data into a form, particularly if it's either one of those, what gets saved is the code, not the data. And that's why you'll hear people use the term, you'll even hear me use the term, a view of the data, because that's really what you're seeing. And it's like taking a photo, and then if you work with it, it's literally like taking a table and photoshopping it, for all intents and purposes, is the best analogy. And this has made it possible for us to take databases into embed them in computers, embed them in machines, and to run hundreds of millions of queries at a time, like Google allows. It does. Now, there's also, if I'm not mistaken, I think I had also got your resource about the binary code. And the binary code is just essential. It's basically a series of ones and zeros. It's very similar to the notion of the binary code came about from the telegraph. And the old telegraph used a system of dots and dashes. Okay, and so when people use a telegraph, they would literally send dots and dashes. And a telegraph operator, my mother was one, knew the code dots and dashes for words, and she had to know them, and you had to memorize them. So as a telegraph operator, she'd sit there and do that, and then eventually it was a teletype operator for a while, and it was the same process. But here's the point with the binary code. Okay, we took that and married that idea. And binary code, a one means a gate opens on a chip or on a chip, and then that translates all up on through the layers of the layers of programming and interfaces up to the human level. When it's a zero, it's closed, and that binary code opening and closing those gates on the chip. The faster you can do it, the faster the speed of the chip, and the smaller the chip, the better. So that's what really revolutionized everything. And I wanted to share with that so you could see that the database is a pretty incredible invention. And when we came with that notion of the ASCII binary code, that opened up all kinds of possibilities for us in terms of storing data and transmitting it. And then this ability to basically take a picture of a database, because that's really what a query is, allows us then to minimize to the storage costs, because we don't have to store. When I run a query and I get a data set, I don't have to store it anywhere. I just store the code. And so that's important for you to know. One of the resources here is Edgar Codd. He is the person who came up with the idea of normalizing data and the process whereby we normalize the data in a database. And essentially what that means is we make sure that there are as few duplicate records as possible. We make sure that we have full records, okay? We make sure that every record is unique. He has 5 conditions or steps. Now, I really just went through the first 3 that are the most important for us to know, but it was Edgar Codd who said he was the guy who really came up with the notion of a primary key to make each record unique, because he said otherwise what's going to happen is you're going to run all these and you're getting all these reports with multiple data, and he was right. So Edgar Codd is one of the pioneers, and we talk about Codd's first order or first level or first law. Second, there are 5, but the first 3 are really the ones that are most important. So I want to go through some of that and talk and speak with you as we start to move into databases. And I also wanted to make sure, again, I can't emphasize enough how, and we just saw this a while ago when we were looking at the New York Times, how the visual display of data is so important. And those maps that I showed you, for example, are really nothing more than a database, okay, with queries run and then displayed in the form of a picture. So the reports you get. Now underneath that, to get the mapping the mapping software is pretty complex, and it utilizes geographic information systems, and it's fairly complex. Although there are some pretty good solid standards in doing that. And the GIS, people often get GIS and GPS confused. GPS is global positioning. It's a position, a geographic information system is how I use and write code to depict the Earth, including things like contours, rivers, etc. I've taken 3 courses on GIS, and it's not for the faint of heart, let me tell you what. And as much as I love maps and all that, I realize I'm not a digital cartographer. I never will be. But it really opened my eyes to understand. And this is a remarkable thing that's happened because every square foot of planet Earth has been mapped. And in many of these countries where they don't have the way they find, a lot of times they'll find where people are at or what was there will be one of two ways: Google Earth, okay, some type of picture was taken, or maybe satellite pictures, but more typically GPS. And that's how they would find people. And that's what's going on even tonight down there. Folks who are who are stranded or on the top of their house, they're going to be found using GPS. So it's more than just something we can use to make money. It's also a way we can organize data, and it has a lot of versatility and uses. So I wanted to talk some about that. Tonight we had a few things due, and these are basically the exams. This was this is from Lake West, where we worked with the Excel files, okay? And so I wanted to begin tonight to move us into working with databases. Now, let me scroll down here, and you'll see I'm down here at the week 4 module, and there are here are 2 resources on recommendation engines. Okay, now a recommendation engine is a database, but it's a little bit different type of critter, and it's important to us in business because a recommendation engine is really more oriented towards the end user, okay, than it is to the storage and retrieval of data. And that may sound funny, but when you think about it, there's a subtle but very important distinction. A recommendation engine does this: it takes your query, okay, and it finds an associated or similar query. And that's why when you go to Amazon, they'll say, well, people who bought this bought that. Or you go into Amazon and enough times in byproducts and stuff, you'll see certain things that they'll put out there. Usually they'll make that recommendation engine will be based upon things they think you might buy. It will also feature some things that they're that they have on sale, etc. So when you log into to Amazon, understand that at its heart, it's a recommendation engine, and a recommendation at its heart is really is what it is. It's trying to direct you and direct your attention to particular things. And it makes sense if you're marketing. Now, recommendation engines are also used in some other kinds of situations. One of them, for example, is recommendation engines are used by folks in law enforcement when they're going through the FBI files, or they're going through the files, and the FBI case in the Perelson book is incredible. And listen, hadn't gotten any better. The database will start to link up profiles of people or similar crimes or their record, and so it's really more like that. Now, so it will be useful for you to take a look at those resources. Now, I want to click on this for just a minute, and we're going to pop over here and look at the 2 different schemas, or 2 basic schemas or diagrams that are used, not diagrams, but designs used to make a database, and they give you a good comparison of the 2 of them. Okay, a snowflake versus a star schema. And we're basically going to be working with in some snowflake types of databases, and what that is typically you'll have a facts table, and again, this is back to the idea of a warehouse that has several tables that feed into it. Usually, a fact table will have some measures, that is, some data that can be counted, etc., as well as foreign keys from other tables. And a foreign key is a primary key from another table that's been inserted. And always think the left table, the right table, the parent, the child, so that snowflake, you know, pardon me, the star schema, pardon me, looks like that. The snowflake tends to use a lot of it tends to use a lot of lookup tables and things of that nature. And the reason that you have, as I mentioned here, like the redundant data, okay, is precisely because it's built for lower query complexity. And the authors walk you through all of that. And notice that they talk about joins. And a join is simply where I link up two tables, okay? And I can do a left join, and that is where I take everything from the left table or table A, and then where they match in B. A right join is just the opposite of that, and then an inner join is where I get just those things. They're together. And it's an information searching strategy. So you'll want it to you'll want to take a look at those, and they do have some examples for you. The difference they show you, for example, here's a star schema, okay, and that is a more typical kind of, that's the most prevalent database because it's the easiest to design, and so folks tend to use them more. And you can see now here's a snowflake schema, and what you're seeing happen is you have this fact table or this main table, and then you have what we call dimension tables. We've talked about that, attributes, and dimension tables, an attribute or a fact or something that I'm interested in. And then we have what one would call a lookup table that feeds this table, which then is linked in to this table, and they just go out and they go out, and that's why they use that term a snowflake, okay, as opposed to a star. And you'll want to look at it because they give you some examples of queries and what they look like. And then they give you some nice data in terms of an inner join versus an outer join, okay? And they give you some information about data warehouses. So it's a pretty decent resource for you, and I would encourage you to take a look at it because it does walk you through the most prevalent ways to design a database. Now, got some other things that are due that on the 5th, and we'll talk about that. And let me right now, let me kind of get everybody on board. I think it's pretty obvious to upload what we've done with Lake West. Okay, I want to talk about these 3 file uploads that that'll be coming up on the 5th and the 7th of September. Okay, and really there's this is a case follow-up, excuse me. This, any material left or other material covered, include or other material covered, and then start on database, MS Access and database, and DBMS database management system concepts, case 20. Now, if you take a look at the lab book, okay, and that's that big green book by Miller, all right, and you look at case 20, that case 20 is going to be the elusive moose RV part, okay? And I'm going to click back over here to the files area, okay? And we'll click in here, and you're going to find a finished you're going to find a finished database for elusive moose. And let me pop through here, and let's go down here, and we'll find, here it is. Now, this is an Excel file that we used to dump some data, and then here's the solution, okay? And that's what I want you to upload. That's the case 20. Now, what I'd like us to do is I'm going to go ahead and download this, all right, and talk about it for just a few minutes. And again, as I've said before, it's a lot easier in Canvas, okay, to download and to your desktop and then save it on the desktop. Now again, just a navigational thing, we've got reports, and then we'll click for all access objects, and you can see we have some tables, then queries, some forms for inputting data, and some reports. Now I'm going to click up here on database tools, and I'm going to click on relationships. And let me show you, we were looking earlier at Snowflake versus a star schema, and we'll see how these three are put together, these tables, how they're constructed. And really what you have going on here is you have that classic start of that, really, a schema. And notice that we have the initial contact code here, okay, and that's into in the table member, and then we have the table plan, okay, and that's tied into the plan ID. So we have a initial contact code, and these would be the parent tables. This would be the child, and what's fed in. Now put your cursor on that little black mark and then click Edit Relationships, and it will tell you, first of all, it wants to enforce recreational integrity. And it's showing you that there's a one-to-many relationship, meaning we have an initial contact code, and we're going to have, and we may have more contact. We're going to have more contacts. We're not going to have just one contact. We're going to have multiple contacts, okay? And then let's click on Join Type, and you'll see this is only includes rows where the fields from both are equal, okay? So that's why I was talking earlier about an inner join. You click on this here, you're gonna see the same kind of thing, where you have a parent table and a child. And enforced referential integrity means if two fields, if they don't match, boom, they're out of the picture, okay? There are a couple of other things here like cascade update related fields. You click that, and anytime you make a change in the table, that cascades back through any of the anything that it's related to. And then the delete, same story. Here again, we have a one-to-many, and we'll look at the join type, and there it is. So this is a fairly typical schema, and we have this members table. And what's happened here in this this database is that it is not designed like a data warehouse, okay? A data warehouse is a collection really of databases, or a collection of tables that feed into what we call a fact table, okay? Now, I want to show you what we're talking about. If I open up this table member, okay, this tells me who the people are, where they're from, their zip code, etc. ad infinitum, okay, all this data. And again, I can right click, or I can go up here on the left, and I can see the design view, and you can see that I've got all this information about, you know, their field, the field name, the data type, their last name, their first name, their enrollment date, etc. And this is a table that would really be begging for the use of some lookup tables, for example, on things like the state, so that you get, and also to use a thing like a lookup mask, okay? Now, I'm going to click on phone number, and I'm going to show you what we're talking about. So click on the field phone number, and then come down here to field properties, and you see a line called input mask, okay? And we'll click on that, all right? And you have some choices in terms of how that phone number is depicted, okay? And in this case, it's you know, with the you know, the area code in parentheses, and then the last you know, the last 7 digits. Yeah, you could do it as such here without parenthesis that denotes the area code. You could use, and again, it's just what works for you and how much storage you have. But this input mask, what it does is it makes the user input the data exactly how you want it. Okay, and that every time you go, every time you go, even let's say if you just go to Google and do a search, and you misspell the word, Google will say, "Did you mean blah blah blah?" Okay, and Google's saying you misspelled it, and here's the correct spelling of what you're after, and is this what you want? Now, the same thing with when you go and buy something, for example, and you put in your credit card number, okay? Typically, they'll have you put that in, and then they'll ask you to put in that little 3-digit ID number that's on the back of your card. Why? Because that little digit is a constant for every card issued of a certain type, but linked in with your card number or your account number, then it provides you a unique set of data or a unique record, and that is, or probably really a unique table, and that is your purchases, your payments, etc. This does not have what we would call a typical kind of fact table. This has forms. It has lots of queries, okay, but it doesn't really have a fact table. So I'm going to go back up here and close this off, okay, and again, this is what you would want to, the Moose solution is what you would want to is what you want to upload there. Now, I want to find the data. Here's the Northwind's data. I want to show you Northwind Traders. This is a little data. This is I didn't want to do that. I want to close this off. I want to download it. So let's download. I'm going to download to my desktop Northwind Traders, because Northwind Traders utilizes a warehouse, a data warehouse, and I don't have any big problem at all with going over it. Now, what they have here, first of all, is a little login. This is a form, okay, and it says select the employee, okay, and it uses a lookup table to select the employee, and then you click log in. The whole idea is to see, okay, who's using this thing, okay. Then what it will do is it will give you I guess a dashboard, okay, for searches, and it gives you some KPIs, meaning key performance indicators. One of them for these folks are active orders. The other is the inventory to reorder. We don't want to, we don't want to run out. Yeah, and then they have some quick links to view the inventory, to view the orders, view customers, purchase orders, supplies, etc. So this has a dashboard, okay, type of effect, and it has a little total revenue picture down here that you can take a look at, and you can see the quantity available and the reorder level, and we're going to have to do some reordering to get the thing up to snuff. So first had person login, then based upon, and the people using this database have the same clearance level, it brings you to this very first little form that asks you, what do you want to go after, okay? And now, I want to take you down and show you a fact table, all right? And maybe it's down here in the queries. They might have converted it to that. Hang on just a second. No, here we go. Well, if you look at these here, if you look at these inventory transactions, This is a fact table, meaning it just lists transactions. It's like a general journal, okay, that you would find. It's a list of every transaction. They have a transaction number, the type of transaction, when it occurred, etc. So it's a facts table, all right? Now, here's the invoices table. Let's open it up. Same story here. And so when you look at these are not dimension tables. A dimension table, using the proper naming, has the three letters DIM, meaning dimension, meaning this is a factor or an attribute, and we use this table to throw that into records. These are all these are not dimensions in the strictest sense of the word, because this is not, or this is handled like a fact table as opposed to a strictly drawn up dimension table. Oh, and now you say, okay, this is wonderful. What practicality is there for being this? And I understand that question. A table, okay, if it's a dimension table, means you have identified the key attributes or factors or characteristics that are operative for your business transactions, okay, or for data involving your internal performance or data involving external or environmental conditions. And those three things, okay, are what make IT decision-centric and what bring you to a dashboard, okay, or build your business intelligence, or allow you to do that, and then ultimately to feed on into company strategy. A database should be designed around the business and what it does, okay? And here, this is they're in the sale. This is a sales business, and it's designed as such, okay. And it really does, it minimizes dimension tables. In fact, I don't think they have a single one. Maybe I'll find one here. The customers would be a dimensions, and employees that might, yeah, inventory traction, inventory transactions, inventory transaction types. So these technically are they're technically dimension tables, but not really. But that's okay. You don't have to have them. But when you, let's open this up for a minute, okay? And this table is an expression of what you want to know about your customers, okay? Now, when I teach operations research or a logistics course, and OBU doesn't offer either one of them, I do sometimes in the summers for some other institutions, I always tell them that logistics and operations management or operations research, but essentially logistics is a physical manifestation of how you intend to get, and how you think is the best way to get stuff to your customer. And logistics, can be stuff that's downloaded over the internet versus an order's placed and away you go, and FedEx gets it, etc. So you have two of those, physical or versus an abstract. But when you have that logistics, it is a picture of how you conceptualize your business. And let me give you an example of a very typical methodology that's followed. If you're FedEx, okay, what you do is you go through a process where you take a bunch of stuff and collect it, okay, and then you take it to a point and you distribute it. So it's like you have this, it's like almost literally like you have a funnel, okay, and then stuff comes in the top, and then you have a bunch of pipes or filters at the bottom that take stuff and distribute it. Now, the distribution or the input, either one, there are any one of a number of ways. And so when you start connecting them, that's how an order starts to flow through a value chain. But if I were to go and say, if we were to go to FedEx site and say, tell us, how does a package get from Memphis, Tennessee to Oklahoma City, Oklahoma? They would have a chart. They would have probably a map that would show you several routes or several routes that they use, and this might involve an airplane, a cargo plane. Those they tend to use for fast shipment of things. More than not, it's going to be through through rail or through truck. If it's rail, it's stuff that's really going to be sitting a while. But usually it's going to be through truck that you'll see on the highway. So it's a physical manifestation of that, and that's what this is here. So when we draw up a database, we need to do it with those kinds of things in mind, okay? Because we're going to want to collect data about that transaction. Now, Northwind Traders has got a series of fact tables. Well, this is a fact table, and some that are more apropos to what we would think it is a traditional fact table. And one would be the sales report. Now I'm going to open this up for a minute, okay? Now this is going to show us, all right, groupings, categories, field source, and as it's populated out, what they've done here is they've treated this like a dimension table, okay? But in here are facts. Okay, and so it's kind of a hybrid, if you will. Now, let's look at the suppliers table for a moment. Okay, this is more like a traditional dimension table. What is it I want to know about my suppliers? Well, I probably want another email address, although I don't seem to have it here. Okay, so Northwind Traders is a good example to work from. Now, I'm going to open back up and let's look at some of the queries. And here they've run a series of queries, and they have customers extended. Let's open that up. And they're using queries. Here's where they're using a query to literally create a fact table of sorts. Okay, and they've got contact name, the file, how it's filed, etc. All that's there. Okay, here's employees extended, and has all that data. Then we come to inventory, which is a fact table in the classic sense because it has quantity on order, etc. Again, the whole idea is that we design the database like a tool, and we use things called, and we call it an entity relationship diagram. And I have in one of the resources over there, and I think I opened it up, is from Oracle. But I want to click on this and show you what I'm talking about. And so we clicked database tools, and let's click the relationships again. And there you see that physical manifestation using an entity relationship. Now there are some tools out there that will let you populate these. Otherwise, these are done in hand, and we could take. I know it looks like a bunch of spaghetti, and we could pull them all apart, and we would really see the schema that's there. I'm going to click. I've clicked on the database tools. I'm going to do this for a moment. I'm going to close everything up. All right, and click on database tools, and then we'll look at the relationships. Okay, and we're going to close that off, okay? And here I'm going to click on a thing called the database documenter, okay? What this does is it lets me see how everything's related, but it's put into the form of a report, okay? And if we want to see all of these, we'll just click these and we'll look at these tables. We'll just select all. I'll click OK. And it's going to give us an entity relationship diagram. Okay? It's opening up here. It takes a little bit to do it, and maybe it will put it up for, it's not responding right now, but hopefully it will. But it will give me a report, okay, of those entity of relationships. And it's just taking its time doing it. For that, I apologize. There we go. Now you can pop it up, and what this will show you, here's for a query, okay, and then the properties involved and the SQL, okay. And this is what you would hand somebody to go and do the physical construction of a database, okay? And we'll close that off. Now, I'm going to click inventory again, and I'm going to click on a thing called object dependencies, okay? Now, I always like to make sure, all right, that we, and let me get the object dependencies back there, okay, and pull this down. And here we're looking at, for the inventory query, we say, okay, is it dependent upon any tables? No. Is it dependent upon, it's dependent upon these three forms, okay? And that's what it's dependent upon. We can click on the customers extended. We'll do that, and we'll run the object dependencies, and we'll see that it's based on that query and the objects that depend on me, objects that I depend on, and it is linked in. It depends upon the customers. This is a way for us to see, or to create, if you will, information flows that seem to make the most sense, okay? And it's also a way, if you have the access or privilege to do it, to go ahead and we'll click refresh on that, and then we'll get it out of the way. It's just a way to do the planning with the database before you build the thing. So I'm going to close this back up here. All right. Now, close that off. So I have objects that I depend upon, objects that depend upon me, and then you start to see that chain. And databases are designed just like a physical value chain. We've moved more and more to that. And give you an example. There are some supply chains that are what we call weight reducing, meaning it's something that's refined. A good example would be petroleum, okay, which is raw crude is pulled out of where it's from, and then it's sent to a refinery to be made into something that we can use, okay? It's not any different than people that go out and, these big diamond companies that will collect rough cut, and then they'll take the rough cuts and then they'll cut them, divide them for their purposes, and send them off to wholesalers who will clean the things up, make it look pretty, and then retailers will come and buy them, okay? And again, it's just, it becomes a weight reducing proposition. An automobile in an automobile plant is a weight gain, and so the information technologies, how they're designed, particularly the databases, have to reflect that fact. And I know I've said it ad nauseum, but a database is a physical, it represents a physical manifestation of how you see knowledge organized in your company. Okay? And it truly is. And it's so obsequious, it's hard for people to understand that. Now, so this Northland Traders is going, and I think I mentioned before the Oracle retail model. Maybe it will render for us, but you can see it's 322 pages, so it's going to take a little bit of time to render it. So I'm going to close that off, and try to download if it's going to let me. Right now it's there. I'm going to download it, and if you're a retailer and you decide to use Oracle and their analytics and their database system, you will. And this is from July 2009. So Lordy, it's proprietary data. Everything that's in here now has changed, or they wouldn't have it out there. But they walk you literally through how they design that database, how everything is pulled together. Okay, so again, it's one of those things where you're talking about trying to do some planning, etc. Now, I'm going to get this out of the way here for a moment. Goes that off, and when you ask me again about what we'll be working with, the Moose solution is a good one. Again, that one is over. That one's over Elusive Moose RV Parks over on 145. Okay, and that case is all about building tables. It's really focuses upon building a table. It's not 145. Let me see. Go back over your case. 148. Excuse me. I'm sorry. And then you can see starting at page 148 as you move through. Okay, table 1, table 2, table 3, table 4. Okay, and those input specifications. And the use of the Moose. So I'm going to click on, let's see, it's find find Moose solution. I don't want to render it. I got to train myself I want to download it again. And we'll open it up, and there it is. And then we'll go and choose all of our objects. Okay. And you'll see this is really more like a classic database, database with naming conventions. Here they're using the table, and then QRY, and this is a holdover from the day and time when you didn't know what you were looking at unless you saw a title for the object. We didn't have iconic display of stuff. And again, you've got the tables, the queries, and then you've got forms to input the data. Okay, so that Moose solution, and I'm going to come back up here for just a minute and go into the modules. Okay, and we'll scroll down here. And that Moose solution, and I've got it down here. You'll want to upload it here, okay? And same time about case 20 part 1 upload here. So the Moose solution is fine there, all right? And again, it's all about tables. And as you walk through those pages, 150, 151, and you see the tables, you're going to see the following things: the field name, the data type, the field descriptions, the size of the field, and any comments. Same thing with the reservation table structure, etc. Okay, and so that case really focuses upon using building tables, and to get as clean a set of data as you can get out of that. Okay. Now, as far as any other material that business left, if you upload Northwind Traders, I'm okay with that. Okay. And then there's another database in there that I want you to open. We'll open it up and take a look at it. And we go over to the files. And that's the one that you'll upload in here. I know it's a little bit confusing, and it's hard for me at times to tell how fast or slow I'm going to end up going. So let's go to the files. Okay. And this is a this is the case Bailey Bird. Okay. And Bailey Bird is case, I'm looking over the database case. And let's look what we're looking at here. Oh, pardon me, I'm sorry, it's an XLS case, isn't it? My brain just went dead. Oh my gosh, I'm sorry. What I want you to look at is we should have second time movies. I apologize. So let's go down here and find the movies database. I'm so sorry. And here you go. Here's movies. The movie. There are three cases there on the movies. And let's start with this first one, movies 4. Okay. And we'll open it up because it's the basic table. Now the movies case is second time around movies, case 19, and it's there on page 138. Okay, and we want to take a look at it for just a few minutes, and we've got we'll put all objects, do it by object type, and we've got just the starting skeleton of their database. Now, over on page 138, they begin the case and they give us some verbiage. Okay, and pop us over here for just a moment. And to get a sense of the business case, they talk about the case scenario and the background, so that you have an understanding of why they're creating the database and what they're trying to get. And then over in pages 140 and 141, they show you, okay, a membership plans table. Okay, these folks sell memberships, so it makes sense that they're going to have a table that reflects that. Then they have a plan type table, that's table 2. Then they have a couple of figures for inputting data, and then they have a comparison chart with some output. And then you'll notice the results of some of those output are over on page 144, and then 145. Okay, you'll see a members type of table. So I'm going to open up table member. Now, this uses the convention TBL for table, and let's open it up for a moment. And you can see this is anything and everything about your customers you did not want to know. Now, there are some things here that I don't like. First of all, I don't like the thing on the newspaper. That aggravates me immensely. Okay, and you got to just try yes and no. But this is all of our customers, phone calls, what kind of credit card do they use, okay, initial contact, plan ID, and newspaper. Okay, so this table. It really is, in a sense, it's a dimension table. Okay. But it's populated with facts, and you're going to find people. It's kind of a hybrid. Now let's look at the table plan, And that one's going to be more like what we would call a traditional dimension table. Notice that we have a plan ID, we have a description, and a cost. These are constants, and a pure dimension table is like a constant that you plug in into an equation. Let's look at the table source, and that's the same story there. This is a classic dimension table, okay? And when we talk about initial contact, we're talking about variables or attributes, okay? Whereas here on the member table, okay, we really have factual data, okay? And this is the bare bones, the very first table that we have. Now, we can run a query on this, and we're going to do that. And let me write, let's see. They have credit card, American Express. So I'm going to close these. I'm going to click create, and I'm going to go to query design. And well, let me do this. Before I do anything, I'm going to close all the objects off except for the query. So I'm going to close all. Then we'll start over. I'm going to click, I'm going to click create, query design, and this brings me to what we call the graphic user interface level. Every user today works at this level. Few people go down and write their own code. Geeky people and people that love writing code do it, and then of course database administrators and people. But typically we work with objects. Now here's a table. So we're gonna drop. We're gonna add the table member. Okay, and we don't have any queries or anything like that. Now what we're gonna do here is I'm gonna get the member number, because that's the key to everything, and I'm going to get the credit card, okay, and then I'm going to get the first name and the last name and the enrollment date, okay, of everybody who's used everybody who uses American Express. Okay, now I put that in as a criterion. Let's see. And there we have everybody who uses an American Express card. As I said before, data, information technology is about taking data and turning it into information, something I can use to make a decision. So I have something here I can make a decision about, and that is, do I have enough business with these types of cards to continue to accept them and pay the fee? Okay, because I'm going to go back. Let me look at the table members for a minute. Let's see what other cards they've got. They got a MasterCard. So let's go back into the design view on this query, and instead of American Express, let's do MasterCard and see what we get. And about the same number. So we've not really, don't really have any big difference between them. This is probably a function of just the authors wanting to show us, because those are all from different. Now I'm going to do another criterion this time. And I'm going to come in here, and on the enrollment date, let me look for a moment. I want to see the enrollment dates. Take a peek. 1906, so 2006 up to 2008. Okay, I'm going to go back into this query, and I'm going to get everybody, okay, whose credit card was MasterCard, okay, whose enrollment date was greater than, let's call it 1/1/2006. And let's see if it plays nice with me. It may not. Oh, it did. Okay. In fact, let's go back here for a moment and let's go into the design view. And we're going to put this in descending order. So we have the latest first, or I could reverse it and do the earliest first. And so there's everybody who has a MasterCard, and when they did an enrollment date with us in 2008. Now, of course, you know, I might want to look at some other factors. Let's go back into this query, and again, we don't have a regular query we're working with. This is just kind of serendipitous. There's the SQL. Let's go to the design view. I've got the enrollment date, and let's see. Let's see about states. Okay, and we'll put the states in. We'll leave it. Let's run it and see what we get. Okay, and there's everybody from MasterCard and from 2006 through 2008, and what state they were from. Now, if I have 1,000 of these, I'll tell you what I'm going to do. I'm going to take them and I'm going to throw them into Excel and then do my data crunching. So I'll use this, you know, just like the refrigerator, and then pull the stuff out and cook the food. Okay, so again, this is the movies. This is their skeleton database, and you can go over and see the kinds of things that the authors are after. But you know, here's the information specification solutions. Okay, I'll download it for a minute and take a look at it. And they had some specific things they wanted to get, and I can look at the titles and see Louisiana membership. And if they're properly titled, it won't be a problem anyway. I'm going to get all access objects, okay? And I'm going to see the table member, table plan, the table source, and then here are all the queries run off that table, and here are the forms. I haven't talked about forms very much, but forms really, you really can't design a form until you know the tables. And the forms are just basically designed to populate the tables, or you could use them kind of like a little kind of search engine. And we'll open this up here for a moment, and you can see I can navigate through records. I can do an open text search. I can enter a new blank record. I can, as I said, I can navigate first to last or to a particular. I can do a search, a text search. So a form lets me input data, but at the same time, what it lets me do is populate a table. Now I'm gonna click up here on the design view. I'll find that, and I think what I'm going to try, I want to create a the layout, the form layout, and let's click this for just a minute. Layout view. Okay, no, that's not what I'm after. I'm sorry. What I want to do is do the type of field. So I'm going to close this off for a minute, and I'm going to click create, and I'm going to use the form wizard. That's what I should use in the first place. Okay, and I'll get all the fields. Click next, and I can put it in columnar or whatever field I want to. Okay, so I'm good to go there. Now, if I click on form, blank form, then I can come in and add objects This is where I add a text box, which is called, and that's where I input data. This is a label. Here's a command button. All right, and I'm going to take the command button here and put it in this form, and this will say, okay, here what do you want this thing to do? You want to work with records, forms, and I'm going to do report operations. I'll click next, and I'm going to get a printer report. I'll click next, and it'll tell me it'll choose which one do you want to choose. Not a big deal there, and we won't save it, but you can do some playing around with it for your own stuff. What I wanted to do is find a split form. There it is. Good. I'm sorry. I'm just not myself today. Click, and I want to click split form and watch what we got. Now here's our enrollment. Here's our form. Okay. But I'll close these shutters, the shutters, so you can see navigation pane. And notice I've got the table below the form. Now, a lot of people like this, okay, because if they're inputting data, they can see how the table is being changed. Okay? That's all that's going on there. So we'll close that back off. And again, this is that movies. And I'm going to look here on the queries, and they wanted to do the count by state. So they have how many customers they have by state. And I'm going to close that form. Okay? And I need to go back to the form view, and I'm just going to close it, and I won't save it. Now let's look at this first query. This is count by state. And here we're going to count the number of members, I would bet you, in each state. And if you'll see right here, all right, maybe this is credit cards. Here's the initial contact code, and really these need to be reversed like that. There's the initial contact code, and that's a one-to-many. And so, okay, let's take a look at this at the datasheet view, and this shows us the initial contact by state. Okay, and we can see that we want to get. We've got the total for each type of initial contact. What we don't have totals for are by the state. So let's go back into the design view on this, and we've got it grouped by state. Oh, and I want to do this is a cross tab, so it's kind of a booger. Let's go back over here. Now, let me say this honestly. I'm kind of a lazy slug, and if I had this query of account by state, in other words, if I had how they were initially contacted, and I've got 500 of these, even 150 or anything like that, this baby's going to Excel, and then I'm going to put it into a pivot table. I can't emphasize that enough. Right now, we don't have that ideal product that combines everything together. We just don't. Folks are trying to move things to that point where you have a full database with a full analytical engine or spreadsheet engine. But closest thing to it is an Excel pivot table, and you'd want to use one here because you want to get a count by state as well as count by contact. Okay. I'll go back into the, and we've got them grouped by, and let's do a count, and let's do the sum, and let's see what we get. Probably going to get an error message. Yeah, they want to group it by, and I'm going to get rid of that for a minute here. I'm going to get count on the states. Let's see what I get. Oh, I'm going to have to do I've got a count, and I'm going to need to do, I think, a column. Yeah, probably not going to work. Nope, it's not. I do not like, I detest crosstabs in Access. So this one, you know, credit card. They want, okay, what are the top credit cards? This one is, where are they from? Pardon me, this is initial contact. This is credit card data. This is enrollment data. And you can see they're kind of, they're using these queries to generate a series of fact tables or list of records. Now, we're going to try something here, and let's look, first of all, let's click on database tools, and let's look at the relationships that are here. Now see if all three tables are connected, because we got three tables. Okay. Yeah, make that proper. We move these over. These are parent, these are child, parent, these are parent tables because those two tables have the primary key fed in. So that's the so that's that flow. Now, knowing that these three tables are connected is good, because now I can try to do a little work with the queries. So let's click create, and we're going to do query design, and click the queries tab, okay? And I'm going to get the query count by state. I'm going to add that. I'm going to get the plan count, and then they've got some, they've run some for different states, and we'll close this off for a minute. Let's just see what we got going on. Well, I'm going to have to the description, and let's run and see what happens, unless we've done something. There we are. Now, I again have now enough records that I would want to export it out to Excel. But now, that being said, if you look above here, you're going to see that I can do some totals, I can do some filters, I can do some work with the query in here. It won't save it, but if I want to, I can do some well, let's click on let's come down here and come all the way down to the bottom of this table, and I'm going to get, I want to run a total, okay, and then I'm going to get another total here. Yeah, and I want another total here and another total here. So now this will tell me, yeah, the count. This again is going to be a count of total counts, and then description. Somebody on me about something. And then the count of the number of plans, and there it is, the total. That would be the sum. Now, look, you don't care that much. What you really care about is the count of the plan ID. Okay, so you don't really care about these others here. You might care about the number of initial contacts, but if you're really all hepped up about that, click above here, and let's come over here, and we'll click home, and let's see if we can do a sort. Here we go. I can do a filter. Let's see. I've got the count. Filter by form. Filter sort. Again, you can see I'm kind of struggling with this in terms of how clunky it is. So I probably would take this and throw it into a pivot table so I can play around a little bit more. Okay, well, folks, we've been on here nearly an hour and a half, and as I said before, I like to keep you till around 7:30. So let's go back in a quick review, and you say, okay, what are we going to be uploading for stuff that's due? And I want to go back there, okay, and I want to click on the syllabus. All right. Now the Lake West thing, which is due, that Lake West, due the 31st, put in Lake West. Then you're going to come to these three that are due on the 7th, okay? And I'd like you to put in on this very first, this one on MS Concepts and Database Management Concepts, case 20. I'd like you to upload case 20 there. That's Elusive Moose. Okay? And then you could put the movie case, 2 of them in each of these bins because I'm going to be revisiting them and taking a look at them. Okay? I'm going to go about 5 or 6 more minutes and then shut us down and then visit with you real quickly about something. What was I going to do there? Okay, so we're pretty clear on what we want to do with the files on the 31st. Lake West University. You got a place to upload it, and then you have your case follow-ups. And I think in subsequent, I'm going to do. I kind of did a lecture tonight as well as a little bit of lab. I'll do some more lab, and then I'm going to also take a look at and talk about some of your case follow-ups. Again, put this, this will be case 20. This is the Elusive Moose. And Bailey, pardon me, second time around movies, two of the databases in here would be fine. Okay. And I'm going to do another lab, and I'll focus on the movies, and we'll talk about them because we had worked a little bit, I think, if I'm not mistaken, with Elusive Moose. So it's about 7:25, and I want to take about 4 minutes or 5 minutes here. And first of all, I would like to say, all of you are here, and let me go through our roster. And I see Simon, glad to have you here. I see 405, whoever that is, I don't know. And Dylan, of course, is here. Dimitri, thank you for being here. Nancy, you as well. Thank you so much. And Owner, I'm not sure who Owner is, but they're incognito, and it's a great incognito. But there are, in addition to me, 7 of us. And I wanted to take a few minutes to just apologize to everybody about what happened last night. It was a system failure. It had been going on all day there at the school, and finally, I guess, the system tuckered out. I called a colleague to see, and I couldn't get into Canvas. I couldn't get into emails, anything. And so I know this is when an inconvenience for you to meet tonight. You have lives, you have plans, and I'm thrilled that I've got as many of you here as are here. And thank you so much for being here. And I truly apologize. I trusted the system to work, and I let you guys down by not having a backup. So I'm trying to think my way through, okay, what can I use as a backup so that we, we can have some semblance of class. Now look, I'm recording this right now, okay? And so when I stop the recording and then load it at YouTube, it'll be over there. And you can go over to YouTube and do a search, okay? And you'd be able to find it, all right? And so you could get that done. But you know, the email and being able to upload a file, all that you can do it. Now I am so very sorry. I do want to let you know that some of the administrative people heard from me loud and clear about how unhappy I was with how things worked out. Because I believe you have every right in the world when I say it's going to be at this time for it to work, and I'm not comfortable that we are kind of trusting you to have trust in us, and then we kind of let you down. So we let you down, and I'm very sorry that we did. And you know, hopefully it won't happen again. But I'm gonna try and find some way to back up or do something if I can to keep us from having to go through that again. Now I'm gonna unmute. You know, a few of you are unmuted, and I'm gonna really unmute everybody as far as their sound. All right, and see if anybody has any comments, questions that they want to add. Anybody? It's very quiet out there. Well, it won't be so quiet when I start going through your follow-ups and talking about them, and that'll be one of the other supplemental labs. That'll be a supplemental lecture, and then I'm gonna do a supplemental lab looking some more at these databases, particularly the movie database. So let me close that down for a second. Again, you're seeing some things. Obviously, I'm in here that you don't normally see. I want to go back to the module one moment, okay? And I want to encourage you again to take a look at these resources about recommendation engines. We can have a whole course on that. And you can see here's the movie skeleton file you'll want to take a look at, and then the solution files and a Word doc. That's then really for the 29th, or which was yesterday, and for today. And again, charting and dashboard resources, and here's the thing from Tornado Town from 538. Again, here's some tools in creating infographics. And again, resources for you to take a look at. And I think it would be worth your while to, the New York Times is some pretty good stuff. I'm going to real quickly take us over to the Weather Channel. And you can navigate over there as well. We're doing a little web safari thing here. And we'll click on it. And it looks like we got another, we have another tropical storm out there. But you can see, here's what I was talking about earlier. As I mentioned, that they needed the water was so deep they needed new maps, okay, and coloring to handle the and we're gonna probably have to see this thing first. All right, let's get to this. I'll have to do a commercial here. Oh, it's a popsicle commercial. That's cool. Well, they kind of fooled me here, didn't they? Let me pop this down here. I want to go down to I want to see the maps. Here we go. I'm so sorry. These are thermals, okay, showing the rainfall total, and then here's the river system data, and they're showing us here before and after Harvey. Fantastic use of an infographic and a database. Okay, that's one I alluded to. Now here's the one, the rainfall thumbprint, and this I think it's one of these is is a new color that they used. Yeah, the white shade is a large swath. It saw 20 inches more. And here's what they're talking about: the had to amend a color table on maps. Okay, so that gives you a sense of how what's going on. And I guess they were showing us some flash flood warnings and so forth that were occurring there. Well, again, I want to say thank you so much, and I apologize for the bad experience you had last night. Thank you all, the 6 of you who are here tonight. I really sure appreciate it. And now there will be 2 more supplemental labs. One of them, I'm going to do some more lab work with the database, okay? And then another one, I'm going to look at look at your case follow-ups. And again, I think everybody, let's see, this is a 29. Anything, what you had to turn in. Let me go back. You had an exam, and then upload. So let's see when the exams are due. I'm going to go over here to, for a moment, to the syllabus. Okay. And I have a couple of ignore this, but these 3 were due. These are due the 22nd. So you should have already done them. This was done. This is here we are. It was due the 29th. Okay. If you had trouble, and I'll go back there and check through, and anybody if you had trouble getting in and being able to finish that quiz, here's what I'll do. Send me an email, okay? And I'll do a reset that gives you a little bit of extra time to get that done, because it's not fair if the system went down to put you into that kind of situation. Same thing with the Lake West. Okay, well, one more time, I'm gonna pop this open and see, Dylan, anything you want to add?
No, I think I'm good.
Okay, Dimitri, you there? I see you here, but let me unmute you. Let me unmute all of us. Dimitri, anything you'd like to add? Nancy?
No, I have a couple of screen share backup solutions that I'll send you.
Okay. Send them to me, please.
I will.
I'd love to. My issue was not with Zoom. The issue was with OBU. But send them to me because I want to take a look. I'm always looking for something different, and
Okay.
Zoom is what the administration is forces
Oh,
on.
gotcha.
But I'd like to see some other. I'm always interested in those types of things. So send them to me. Now,
Okay.
Let me see here. I have somebody as a question or chat. Okay. Oh, okay. All right. You're muted. Okay. And let me go in and unmute you, Dimitri, and see if I can. I unmuted everybody. So, Dimitri, can you? You're unmuted. Question, comment? Or are you still having trouble? See another chat. Oh, okay. Your mic's not working. All righty. Well, folks, if you have anything else, Simon, anything you might want to share? Okay. I'm getting another chat notification. Okay. All right. Folks, again, thank you so much. And I appreciate you being here tonight. And be looking forward for those supplemental links. Now, here's what you need to upload for those assignments. I've covered that. So you'll want to get those done. If you had any problems with anything that was due on the 29th, okay, which was yesterday, let me know, and I can move the quiz date back for you. That's not a big deal. Again, thank you so much, and I'm going to stop the share, and then I'll stop recording and end the meeting. Thank you, folks, so much. I really appreciate you coming out on this alternative night.